Hello and welcome back to KubeCon 24 in Paris. I'm here with Alexey with Intel. Alexey, good afternoon.
Hi, everyone.
Alexey, what do you do for Intel?
I'm a cloud software orchestration engineer, so I develop the stuff that helps running workloads in Kubernetes with Intel accelerators, whether it's a GPU or FPGA or QAT or something else.
Fantastic. And that's actually what we asked you to come in and talk to us about today is some of the cool things that Intel's doing with GPUs.
Excellent. Right. So you might know after the last KubeCon, the abbreviation DRA, some say it became a DRA-Con instead of the Cloud Native and Kubernetes Con. Right, so that stands for Dynamic Resource Allocation. And our lineup of the data center GPUs is capable of the single root input-output virtualization, first SRIOV, and our DRA resource driver can dynamically change the configuration of the GPU, allowing better isolation of the GPU resources for the workload so that they don't interfere with each other. Without the isolation, there can be a noisy neighbor problem when one of the workloads hogs all the resources and the other workloads on the same GPU just suffer. And with reliable hardware level isolation, and this problem just doesn't exist. So traditionally, you might know that there were device plugins and they allowed the workloads access to the accelerators, but they are fairly crude and simple mechanism to allow access to the whole device and to get such a device shared between the workloads, as the engineers and the administrators had to install additional software into the Kubernetes cluster, something called scheduler extenders. There is a Intel provided scheduler extender called GPU-aware scheduler extender, and that helps abstract the amount of capacity one GPU can potentially have, and then it's possible to use one GPU with several workloads, but then sharing such GPU in this way is based purely on the promise. So if the workload says I will use only half of GPU, I promise sometime future down the road that such a promise can be broken and suddenly the resources are hogged by one of the workloads and you have a service degradation and all the consequences in this case. Now with the DRA that's available since 1.26, we're able to do a preparatory step before we allow access to the container or the accelerator. And we can split into GPUs. In this case, I don't know whether we'll show the actual video of demo of how this operated in cluster. It's actually online. You can go and check this video, how to share and isolate resources on the Intel resource channel on the YouTube. But briefly, the DRA resource driver tells the kernel driver to prepare GPU splitting into several different pieces, whether it's unanimous separation, like 1/4 of the GPU can be allocated to a particular workload, or if you want to run half of the GPU with one workload and then 2/4 for two workloads.
So really what you're doing is proper sharing of the virtual GPUs, right? So I can take a very, very powerful GPU and really split it up into multiple segments and allocate that to a specific workload or different workloads and let them share it properly, right? So that one's not clogging it, one's not taking all the processing power, and I can really minimize the amount of very expensive GPUs I need to purchase, yet be able to run a whole bunch of different workloads.
Yeah, that's the idea. You can actually, the idea is that first you use the same huge powerful GPU to train, if we're talking about the AI, you use them to train the AI model, and then you can inference on the same GPU, but then you don't need the same amount of resources. So you can use like 1/4 of the GPU and you can run 4 different inferences with the same GPU efficiently and reliably.
That's fantastic. Now, since this is created by Intel, is it tied to specific processors, specific types of video boards? How does that work?
Yes, with DRA, the expectation is that the vendor of the hardware will provide such a resource driver that will be responsible for a particular device. Later on, the plan is to have also something like a combined resource driver. So for example, if you need a GPU together with the very fast network interface to connect to another node or to another GPU, that will also be possible. But at this stage, we only orchestrate the GPU itself or a QAT device that's in the pipeline as well, or maybe some other accelerator.
Cool. Any other devices that you see in the future this working with, or is this mainly for video report?
We're starting to work on the QAT accelerator because that uses SRAV feature as well.
Yeah.
So that's going to be available after the GPU. Hopefully, quite soon.
Awesome. And what is the current status of the project? Is this released? Is this generally available? Is it early access?
So there is two parts to this question. One is the framework itself, the Dynamic Resource Allocation. That is released. It's a part of the official Kubernetes source code and the release. And that has been around since 1.26. And then on top of that, we have our resource driver that has been available since 1.5 years ago as well. But both of them are in the alpha stage, so to say.
Yeah.
So because the feature is still being developed in the Kubernetes, and you have seen plenty of talks at this KubeCon about how it will be developed further. For the end users, luckily, this is going to be completely transparent. After the current design will be slightly adjusted in the next 2 releases. That's what's in the pipeline in the DRA itself. We're going to adjust to the new model as well, and there will be subsequent versions of what is available right now, the GPU resource driver. And then we just upgrade your cluster with this software, and you don't see any changes. So it all happens in the behind the scenes.
And that development cycle right there is really what I love about cloud native and open source. The fact that you're in an alpha stage, you're really defining what the product does, yet you make it available to customers to look at and really give input and really shape the future that it goes. I mean, that's what's great about cloud native and open source, because the customers help define where the projects go. And that's really the key.
Yeah, I cannot agree more.
Awesome. Well, Alexey, thank you so much for sitting down and talking to us about what Intel's doing with virtual GPUs.
Thank you very much.